measuring the 50% hemolytic complement CH50 activity of serum. You will need a pipette able to deliver 200 microliters and one that can deliver 1000 microliters. Test serum which has been stored on ice, sensitized sheep red blood cells, veronal buffered saline, and distilled water. Tubes for the test sera, and tubes for the baseline and total lysis. A vortex mixer, and a 96 well flat bottom plate. Label the tubes individually with control and the final dilution. In this case we begin with a 1 in 8 dilution. Continue with twofold dilutions, giving rise to a 1 in 16, 1 in 32, 1 in 64 and 1 in 128 dilution. Label the remaining tubes blank and total lysis. Once all of the tubes have been labelled, you can now begin to dilute your test serum. Start by transferring 300 microliters of veronal buffered saline into a fresh tube. Now transfer 100 microliters of serum into the 300 microliters of veronal buffered saline. This will give you a 1 in 4 starting dilution. Ensure that the serum sample is thoroughly mixed. Now transfer 200 microliters of veronal buffered saline into the tubes that have been labelled previously. Also add 200 microliters of veronal buffered saline to the 2 blank tubes. To the total lysis tubes, add 200 microliters of distilled water, not veronal buffered saline. Now transfer 200 microliters of the 1 in 4 diluted serum into the tube labelled 1 in 8. We have previously transferred 200 microliters of veronal buffered saline into the 1 in 8 through to 1 in 128 series of tubes. This will now give rise to a 1 in 8 dilution. Mix the sample well and then transfer 200 microliters into the tube labelled 1 in 16. Continue until the entire series of tubes have been diluted. Discard 200 microliters from the 1 in 128 dilution so that the final volume is 200 microliters. The sensitized sheep red blood cells may have settled over time. These will need to be resuspended by gently inverting the tube a number of times. Once thoroughly resuspended, transfer 200 microliters of the sensitized sheep red blood cells into each of the prepared tubes. Ensure the serum is thoroughly mixed with the red blood cells. Sensitized sheep red blood cells added to the blank tube will allow you to determine spontaneous lysis, while blood added to the total lysis will allow you to determine the 100% value. Using a vortex mixer set on low, gently mix each of the tubes. Now place the tubes into a 37 degrees Celsius water bath and incubate for 30 minutes. After 15 minutes incubation, gently vortex the tubes once again and incubate for a further 15 minutes. After incubation, transfer the tubes to a centrifuge set at 4 degrees Celsius and centrifuge at 1500 G for 5 minutes. After centrifugation, carefully remove the tubes and place them into an appropriate holder. Here you will see the pellet of red blood cells, while the supernatant appears red due to the release of hemoglobin. Transfer 100 microliters of distilled water into the required number of wells of a 96 well flat bottom plate. Being careful to avoid the pellet, transfer 100 microliters of supernatant into an appropriate well of the 96 well plate. Once all the samples have been loaded onto the plate, read the absorption using a plate spectrophotometer set at 540 nanometers. Here we have the raw absorption data for the two replicates. A1 and B1 refer to the 1 in 8 dilution. Then we have the data for the 1 in 16, 1 in 32, 1 in 64, and 1 in 128. A6 and B6 are the blank, while A7 and B7 are the total lysis. Once the data has been collected, you need to calculate the mean absorption for each duplicate sample. Then subtract the blank absorbance, which is your spontaneous lysis, from all samples. Once all the data have been collected, you can now calculate the percentage lysis for each dilution using the following formula. Once all the data have been calculated, plot the percentage lysis on the vertical axis against the serum dilution on the horizontal axis. The resulting graph can then be used to calculate the dilution of serum required to lyse 50% of the sensitized sheep red blood cells. This graph shows the percentage lysis plotted versus the fold dilution of the serum. A line can then be drawn from the 50% lysis until it intersects with the curve. At the point where the curve is intersected, a vertical line is drawn down to the horizontal axis. This value represents the fold dilution that the serum must be diluted to ensure 50% lysis. When comparing two serum samples, in order to determine if there is a difference in the CH50, the dilution which provides 50% lysis can be used as a measure.